So again, good morning or good day to you, and welcome to our webinar. It's very nice to see you and not see you, unfortunately, but we will work on that, or rather, there will be an opportunity to see each other after the webinar. First of all, we came here together to listen to Frederik Kerber, who is head of the Innovative Retail Laboratory at the German Center for Research in Artificial Intelligence, and to Dr. Sönke Knoch, who is a researcher and developer at the German Center for Research in Artificial Intelligence. And we are, or I am three. So one of my colleagues is monitoring the chat, and I am the moderator. We are from the Competence Center at the University of Luxembourg, and we are also representing the Luxembourg Digital Innovation Hub, at an EDIH initiative. We also are representing today, as our two speakers are from Saarbrücken in the German Saarland. We are also representing the EDIH in Saarland, and we are proudly not just sponsored, but all of this here wouldn't be possible without the funding given to us by the European Union in the Digital Europe program, which you see on the lower left of the slide. The Digital Europe program is composed of many different parts and components, and the European Digital Innovation Hubs are part of the right of the outer right section there, and our task, or the task of our collaborative together, is to ensure the wide use of digital technologies across the economy and society, and more specifically in the regions that we find ourselves. That I don't want to go further into that to not take time for the speakers, to take time from the speakers. But if you're interested in knowing more, you're always welcome to contact us afterwards and to network after the presentations. Just a few words to the Competence Center, which is us as a member of the EDH collaborative here in Luxembourg. We are responsible for monitoring trainings. We publish a training catalog, which is updated every year or even every 6 months. And the goal is to provide a more relevant selection for especially the manufacturing and the production sector of Luxembourg, where we can promote trainings and where we can promote avenues for upskilling for companies. Beside that, we also help companies with our DSMA, the Digital Skills Maturity Assessment, to better allocate their upskilling needs and to match them with the trainings offered. And last but not least, down below, we also work with all relevant training companies to develop new trainings and positions which better fit into a digital industry 4.0. Then, shortly, we have another webinar scheduled already, so allow me to advocate a little for this one as well. It's going to happen on Tuesday, the 20th of February at 3 p.m. And we are going to have speakers from Tech Academy and Carraro Group. So without further ado, let's get to the presentations. The schedule is as follows. The presentation will last 20 to 25 minutes. There will be a Q&A session following each presentation in the chat. And after both presentations are complete, we will have an open Q&A networking in breakout rooms where all of you can talk as well. So I'm happy to introduce, or to allow you to introduce yourself. Who wants to start?
Yeah. My name is Sönke Knoch. Nice. Thanks for having me here. And yeah, I'm from, as you already said, perfectly introduced myself. I'm from the German Research Center for Artificial Intelligence and speaker for Synergizing AI and Industry 4.0. Shall I start, or is Frederik introducing himself as well? Or? No, okay, I'll start. So let me share my slides. Okay, now you should see my presentation. Works? Perfect. Okay, yeah, then let me start. Yeah, so I will talk about two large fields and try to show you how there can be synergies when you build on one of the technologies and how you can benefit from that for using the other technology. And yeah, of course, these two are very recent developments. I mean, Industry 4.0 maybe the older one if you look into the first industrial revolution back, and I a bit younger discipline from the last century on started, and of course actually right now very famous due to technological developments in hardware and also then the possibilities that were possible in software. I want to start giving you a brief overview about the institute where Frederick and I are from. It's the DFKI, it's a German research institute concerned with artificial intelligence for about 30 years now. There were times where it was very rare to have an institute only concerned with AI. I think now there are more and more institutes because there are a lot of people and companies are requesting it. And we started in the southwest of Germany, so very close here to the French and Luxembourg border. In this international region, in Saarbrücken and Kaiserslautern. Kaiserslautern is also our headquarter. And during the years, more and more sites were founded. So nowadays we have in the north these three sites in Bremen and around. There are a lot of concern with robotics in this field. Lübeck, more with the health domain. An office in Berlin, and Darmstadt and Trier also joined us in the last years. And for us, we are not doing basic research as other large institutes do. We are very closely connected to industry, and that's very important to us. So one would say it's more applied research. So, of course, we have also competencies in different fields. Basic research, we are connected good to the scientific domain, but it's always important to us to see and to show how the technology, how the results can be used in the real world, and to identify new challenges from this application side. So different companies are also shareholders of DFKI, and this allows us to stay connected to the real world problems, to the industry in particular. So the domains are very diverse. If you want to define AI, it's usually something, it's kind of an agent that reacts on input that was sensed. It might be a simple text input, but it might be also complex inputs measured by sensors, and then a certain output recommendation on assistance is generated based on learned rules, learned behavior, on different kind of rules that might be learned or that were learned or defined by users. That also changed a bit in the last years. And yeah, DFKA is researching in these different fields. So we are organized in different research departments headed by professors and the respective universities at the locations of DFKI. And yeah, it's with the classical fields like knowledge management, image understanding, language understanding, but especially language understanding, not only the last year, but for several years now. And it's very interesting to see that now such a boost in this technology was seen to ChatGPT. Yeah. Other fields joined: augmented reality, graphics visualization, simulation, but also the interaction between human and technology is very important to us. So we always see AI not as a tool for making everything work automatically, but more how can it assist the people, yeah, in companies, but also in smart home environments, smart cities. How can it assist and make life or work better in this complex world? So our research department, Cognitive Assistance, headed by Professor Krüger, is also divided into different groups. So we are having projects concerned with smart energy systems. You see here some images where the pipelines are visualized using augmented reality. You can select some of them and the cables actually, and see the consumption charts. So that this is what was one example here. The city in Saarland that allows to make things visible for constructions, planning constructions, for example, or maintenance work. AI parallel computing is also an interesting field where, because it's not always so easy to make a problem fit in a way that you can apply parallel computing, and it requires a lot of effort. And this is a group. Its goal is here only to formulate problem in a way that you can make very fast computation through parallel computing. Yeah, human-centric AI in production. This is my group. I will talk about that on the next slides. Effective computing, also interesting because it's has to do with emotions, measuring emotions. It's, for example, for human resources, it's an interesting field to understand the emotions of an interview situation. Yeah, how you can address these and make the interview in a way productive, that you really understand what the applicant is the right fit for your company. Adaptive interfaces, dialogue systems. So this is not only about chatbots, it has also to do with avatars or interfaces, making the dialogue between human and machine smooth and in a nice way, in the right direction. Human-robot communication. There we have also a lab here in this region. I will also show later a few videos taken in this lab. And last but not least, ambient assisted living, concerned to making this living conditions with assistance systems for people, for example, also with handicapped people, better. So very also interesting projects in this domain. And finally, innovative retail, but therefore Fredrik is here, so I will not talk about this. Good. Let us start with the topic. Industry 4.0 is now, I think it's more than 10 years old when this term was coined out. So the idea was And I also worked for this whole time in projects related to this field, and I saw how that developed. So it was meant by also by politics to kind of force the industry to change something. So the third revolution was the automatization of production, and then here the networking was just to bring IT knowledge together with manufacturing knowledge. So that could be said as I think that was the main goal, and to make production ready for the next decades, and challenging also on the international competitive market, making them still viable. So of course there was seen that this classical way of production changed. So we are getting more and more away from mass production. People want more and more their own individual product experience. So we come to smaller lot sizes, and this means that classical automation is not in any case the best solution. And here we think, it's really necessary to have more assistance in production in order to address this. Because if you have a lot of variation in production, you need to change the machines. The whole setup is not that fixed anymore. It has to become more flexible, with a lot of consequences for the whole setup procedures, for safety procedures in production. This comes along with a lot of challenges. Of course, the whole systems need to be adaptable. The learning curve for workers might increase due to the variety in production. And that might also lead to error rates. So you need new ways of quality assurance. Not in the end, but maybe directly during the production, in parallel when the manufacturing happens, so that you can intervene when errors happen and recommend solutions during runtime. So what is the overall Industry 4.0 approach? So it is the networking of all stakeholders involved. It is an increased transparency, mainly achieved through sensor data. So there might be machines that produce data out of the box, but the challenge then is to fuse all that data and to integrate it. And if you don't have any data about something, then you need to add sensors in order to elicitate the data for KPIs or numbers you want to monitor and analyze in order to make the production optimal. And finally, then, what is the result? That you have some sort of assistance that allows decision making not on a centralized way, but decentralized. So distributing the decisions making, among different stakeholders. Okay, what was the solution? That is an important part of this is the digital twin, and the realization of that is called asset administration shell, and its submodel. So see, here's a typo. It's a German ist, but this is meant as an English is. What is it? It is kind of a language that enables you to describe all your things, your assets in the production field. Could be also applied to other domains. So if you think maybe in the English environment, the term industrial Internet of Things is also very common. It's similar. So you need something that allows you to make information about all the objects in your working environment understandable for machines, and therefore there is this asset administration shell concept that is also standard and suggested by the International Digital Twin Association, IDTA, and it allows you to become independent from manufacturers. Yeah? So you have this common language for describing your assets, independent from any manufacturer of those devices you're using. It allows you also to cover the whole life cycle, because it can direct you to information like documentation about the device, about the origin of the device, about the operating hours of the device, maintenance informations, and all that can be made available through this administration shell. So it's a shell for all the administrative stuff around the assets. And therefore, of course, I think this is one of the most important points, it provides a structure for data and services. So it can be also used not only to describe the devices, but also software pieces and services in your company. Yeah, and thereby it allows you also to technically, software technically access those information. So in parallel, it provides a technical interface to access this information. So it's kind of an, you could say, dictionary about your things and services. Yeah, here you see an image that makes it a bit visible. You have someone here accessing information over REST or OPC UA, for example. And then you have some production process here where some products, here those boxes are transported, and you have a machine, a robot grasping those things, conveyor belt, and the digital twin then exists for the whole production process, for those products involved in the process, and also for this robotic device here in this example. And finally, of course, if you have that, then you achieve interoperability between all those systems. So not only someone from accessing monitoring information from outside for reporting concerns can use that information. Also, the things in the production can communicate over those interfaces between each other, so they are networked in a network together now and can communicate. So that's the main point. Okay, if you now look on the data requirements for artificial intelligence on the other side, if you think of machine learning, for example, I chose here a data mining approach, where this chart is taken here from Agarwal from IBM Watson Research Center, from his textbook. It requires, of course, large data sets always. In order to make a machine learn something, you need as much as data as possible to make a good model. So that means in consequence that you need a continuous supply of high quality data. So far the functional requirements. Non-functional requirements would be, of course, privacy and security, which need to be satisfied, and fairness and explainability that comes into play. You need to understand, if you need to understand how the model was created, because there might be a bias somehow, depending on the data set where it was trained on. So maybe in ChatGPT, a lot of people realize that it is a bit biased by the North American data, and it was seen that it is a bit very, very friendly and very finds things awesome and so on, because it's a part of the culture in North America, and that was kind of learned in the data set, and that's why it behaves like that. So you need to know on which data it was trained in order to understand this. And if you look on this pipeline here, which starts with the data collection, continues with data pre-processing, and then with analytical processing. So this is in the end what you want to do when you achieve the output for the analyst. But the first two steps take a lot of time and effort. And if you were involved with machine learning or AI project, I think you will have realized this are the most critical points. And so since data collection is so important, and it involves, I mentioned it here on the slide on the right side, data acquisition, labeling, the improvement of data. This is why I want to say here that Industry 4.0 can be something that creates the right environment for applying and using artificial intelligence. Since this is administration shell, which gives the structure and forces you to tell what your data is about, not only to write it somewhere to some data space, but to describe your data, give it meaning. This is a very important preparation for doing then interesting stuff like analytics, statistics, but also machine learning and AI. Okay, and the good news is there is an open source implementation for the realization of digital twins. So we are involved with several other partners in a long-lasting project called Basis. Yeah, there were a funding period of about 8 years now, and there, together with partners from research and industry, an open source software solution for this for working with digital twins was realized. And there exists, it's called Basis, and there exist software development kits for different programming languages like Java, C# and C++. It involves also a registry where you can host them, so that in order to make the software interfaces available to accessing all that information about the described assets in your production or in your environment, a working environment. And it hosts those files. It also involves an explorer that allows you to edit, to work on this information in the asset administration shells. It's an editor. And here I provide you some links where you can access the documentation and information about that if you're interested. We have also several testimonials so far. A few companies here mentioned using it, and so I think this is a nice thing also, especially for SME, where you don't want to have a solution from a commercial provider. Such open source solutions could be a nice opportunity. Okay, now I'll show you maybe some examples what can be done with the built on that technology stack. Yeah. So first one is here.
Just for real-time control of the assets involved. The Basis middleware for Industry 4.0 uses.
Switch off the sound. Sorry. So this is actually a view in our laboratory in Saarbrücken, and here you see that we are concerned with human-robot interaction. So here we have an autonomous platform, and here you see the simulation or the virtual environment that models all this environment. And this is realized based on the asset administration shell description. So the whole laboratory you see here is described in the way I just presented. And then we can access information about the position of the robot, for example. Since we have these models all here in 3D, it can be used to calculate distances and in this project here, it was used in order to coordinate different robots here and plan the routes of the robots on the fly. So based on their position, so there might be some behavior that was not planned because there's maybe something in the way of the robot and the route has changed or the material was taken. Then the planning can be changed, adapted, and you see also here on the upper right side where the information from the asset administration shell about the assets here, AMIR 100 is displayed and showing the status, current status of the asset. Yeah. Another example is in the safety domain, which is also important because it's also a requirement by law that when a machine changes and the changes are more often in Industry 4.0, that the safety has to be and the risk have to be checked again. And here we developed together with experts a model or a description in the asset administration shell for risks and safety measurements. And here you see a light barrier, for example, making this press safe, and we used augmented reality display to indicate when a robot is approaching. So when the worker is focused here on the assembly station, an AGV might approach and it's out of view from the person here, shown by this avatar. Then using the distance measurement between the person and the robotic device, we can then, for example, warn him. But of course, this information can be also used to make risk assessments in order to check the safety here and have some tool bring the information about the different devices involved in this production process into view. Yeah, so makes it a bit more easy.
I need to inform you that that time is up already.
Okay.
But you have 5 minutes if you stop now, and otherwise it might reduce the Q&A session a little.
Okay, yeah, thanks. Oh, it was fast. Actually, yeah, you're right. 5 minutes. Okay, yeah, finally here you see, let me just conclude, you see the different models, some examples how that looks like in practice. So you see here how the information is actually edited by the users. We also use that in order to show gaps. So where for example, looking at it on the safety, where risks are not handled so far, so you can filter for things that are missing. Yeah, and that is one thing, and can provide recommendations where other risks has already have been already addressed by certain measures. Then you can recommend similar measures, for example. Okay, then the last example I will skip. I hope I was able to show you somehow what for the administration shell can be used. We think for workers and engineers involved in manufacturing, it's a very interesting, powerful technology. We are also in contact over ADR and another regional advisory, funded advisory project, in contact with a lot of SMEs and other companies. And we can assist. Let me say that finally, and thank you for your attention. And now I hope I can answer one or two questions.
Thank you for the presentation, and I have a question myself, but before that, let's start the Q&A session. And everybody should see this screen now. I will put the first question on screen, and that's coming from. Can you see this question on screen?
I see. Yeah, which one is the first? Let's see.
Yeah, now I see it.
Okay, perfect. The first question is coming from Abraham, and he's asking, you seem to use AAS and digital twin interchangeably. Would you rather state if they are complementary or distinctively implemented in digitalization as regards to Industry 4.0?
Yeah, good question here. Thanks. So the digital twin is a more abstract thing. Yeah, a lot of people talking about it with a different meaning. Some mean that you have a 3D visualization of something. I think it's more the result of what we do with the asset administration. So it's only one aspect of it. It provides the information structure, or more. It provides you a tool to describe your data. Yeah? So it's something where you can say, okay, I haven't said a risk, for example, in my company, a risk contains always some force, maybe in this press example, and this needs to be handled, and then you can think about the consequence, about visualizations and things. So I hope that is clear.
Abraham, does this respond to your question? He can't say anything, but
yeah.
If not, then there's a second question, or if it does satisfy the answer, then there's a second question I would publish here, coming from Matthias, and he's asking, I wonder what is the computational complexity required by the digital twin?
Yeah, so computational complexity. Yeah, it's not very, I would say, not a very complex thing. So you need to host it. Yeah, so it's using Docker for this. So it's a software technique to make it software available independent from the platform. So that needs to be used. Of course, it's some. You need to have some expertise in this. Yeah, it's not that the most easy to use off-the-shelf software you could choose, but it's also still under development, and so that's why I would say it's not that complex, but it needs attention. But what you get then in the end for that is, I think, should be a good motivation. I hope it was answered. And then complexity and so on then is more concerned with what you then do. If you really have some hard problems, in computer science problems you want to solve, then complexity might get more critical. Mm-hmm. I hope that was a good answer for you.
He says, yes, thank you. And there's a third question, and which has to be the last, unfortunately, due to time. You can connect later in a breakout room where everybody can talk. So, which data type and for which application area are knowledge graphs mostly used? For which data type?
Okay. So it's for which type of data, I think you wanted to say. It's especially good if you have a lot of connections. Yeah? If you want to focus on the relations. So here actually we were using it. We had all the assets described and we imported it into the graph database. So but we did not pull all information into the graph. We only wanted to look on the connections between the assets. And in this case, it was important to us because we wanted to focus on this handled risks. Yeah? So we wanted to check if every risk has a handling safety measure. And if you look especially on connected data, then a graph database is good. So social networks or things like that. It's not good if you use it for, as a relational database. Also, if you put all your data simply into it, then it performs not good. So you need to use it only for specific things like connections. Yeah. Yes, we had a lot of nodes, but yeah, good. I think it was answered.
All right, then thank you. And like I said, so later there's more time. Let's get to Frederick's presentation.
Yeah, thank you. So then I will share my screen. So I guess you should see it now.
Yes.
Okay, perfect. Yeah, then also thank you for having me. My name is Frederick Kerber, and yeah, as Sönke already introduced, I'm also working for the German Research Center for Artificial Intelligence. And the DFKI has 9 so-called living labs as research and demonstration platforms for application-oriented developments. And these laboratories simulate real conditions in order to test and evaluate innovative technologies. And the innovative retail technologies, which I'm heading, or IRL for short, deals with specific questions about how the retail of the future can look like. We are located in Saarbrücken, co-located in the Co-Hub 66. It's a collaboration of different academic and industrial partners. And we have, as you can see here, for example, we also have a Fab Lab where we investigate how prototyping can be made with 3D printing, laser cutting, things like this. We have designers there that help with developments and things like this. And so we are doing active research there basically. So if you consider what we're doing there, as I already said, research on our own basically, but also, as we call it here, research as a service. So also if others come to us with specific research problems, then we help them understanding their issues basically, or find solutions for them. And as already said, we're doing a lot of prototyping and try to bring over ideas from the research world basically to practical applications. And we also do workshops and trainings there so that also others can learn basically from our expertise. And last but not least, we are also doing some technology scouting so that we are looking on what's currently going on in our domain and so on, so that we can transfer also knowledge from this to others that are working together with us. For today, I selected basically 3 different, what we call motivations or trends that drive our research, and try to give you some impressions what we're doing there. Let's start with what we call connected retail. So basically the idea of connecting online and offline retailing. So for example, you do a click and collect where you can offer where you can shop the offerings from a certain store while being at home, and then you drive to the store and simply have to pick up things like this. So this is basically what we consider under the term connected retail. And if we now consider how artificial intelligence can help us with such situations, we see that basically data is really important, as Sönke already mentioned. So we need really harmonized and well-maintained what we call master data, because that's basically essential for the success and competitiveness also with other players on the market. A lot of other processes are based on this data, and if the data is not accurate, or you have, for example, duplicated data or data is missing, then all your processes that are run afterwards have issues there. And on the other hand, we also still have the problem that there are a lot of complex IT systems, some very old, others rather new, and so on. And you have to combine data or information from all these different kinds of sources. Basically, they have different formats and so on. And so in the end, it's difficult to handle all these data. And that's why we think that artificial intelligence can help in such situations. I brought a small example. So what you can see here is a small list of customer data, and there are some issues in this list. As you can see here, I marked them here. So there are things that are more obvious. For example, in the fifth one, they're simply missing the city, or in the one before, you can see, okay, Berlin is not in France, for example, but there are also more subtle ones, like, for example, there's a typo in the zip codes for Vienna or Munich, or as you can see in the first line, there's a duplicated house number because it's already included in the street name, and then again, there's the separate column of the number. And as you can see now, of course, you can go and try with a manual approach to find all these issues if you are maintaining your customer data. But as you can see here in the visualization, you need a lot of people, a lot of power to find all these things. And still it can happen if there are very small or subtle things that you can still miss some of them. And then in the end, you still have data that is not 100% reliable. Another approach, basically a little bit from the past, but still used widely today, is that you have such a rule-based approach. The idea of such a rule-based approach, basically, you have a number of rules, basically. So, for example, if the country is Austria, then the zip code should only be 4 digits. That was one of the issues before. As you can see here in the original data shown before, there was a 5-digit zip code. So if the rules are checked now, then you check, okay, you see country is Austria, but then in the end, the zip code is not 4 digits. And then, so basically this rule is violated, and then you can act accordingly. The issue with this is, you might imagine, you have to define all these different rules. And so in the end, it's still a lot of manual work, or you have to try to find different rules. And if some new things come up, then you have to define new rules and so on. So in the end, it can still be an issue. And you still need people, especially the experts, to define your rules, basically. If you now consider a different example, which is probably a little bit more complex, then we have here product data, for example. And if we now try to find issues, then it might probably not so easy to define any rules here. So I again marked some of the issues, and as you can see, it's not so obvious here anymore. So for example, in the first one, it might be quite easy. You see here in the description, it says 2 meters, but in the end, the length is 3 meters. So this might be something that you can easily spot. For the second one, you already need some more context knowledge. You see here the description is ultralight, but then you have a weight with more than 400 kilograms. So in the end, then of course, if you know that ultralight means, okay, it should not be so heavy, then you can spot that maybe the weight is an issue. Or for example, if you check the third and fourth product together, then you see, okay, the 5 meter thing only weighs 200 kilogram, and the one all the same dimensions, but simply twice the size, but it hasn't twice the weight, but 3 times the weight. So you can see here, you don't only have to check the rows one by one, but you also have to see how they perform or how they match together, for example. And then the last one might be another kind of issue. You see here, for example, you have a thing here that is more than, I think, what is it, 100 meter long. So probably something you cannot really ship or something like this. So probably there's some issue here with measurement units or things like this. And as you can see here, it might not so easy to define rules that cover all these things. And this is then where basically an AI-based approach can help here. And what we have here is, and what I think you all have heard in the past few months, are these foundational models. So basically large and universally applicable language models that are basically pre-trained for specific or for non-specific application areas, but then you can go on and fine-tune them for your specific circumstances or for your specific problems you have. And then such a foundation model can take into account information from very different sources and also different modalities. So you can work with image data, you can work with text, you can work with video data, and so on. So you have really the possibility to integrate all this knowledge in there. And then in the end, with one such model, you can solve really a variety of tasks then, if you basically fine tune it or use it according prompts, what is called. And if we now check where artificial intelligence can help us here, then we see some of the examples, or basically based on what you already seen in the examples. So you can harmonize data from different data sources. So for example, if you have things like in the country information is missing in your one data source, then you maybe can look it up in another mapping, for example. Then if you have some deviations or anomalies, as we have seen before, then you can detect it. Or you can also identify duplicates. It's also something that is a lot of work if you do it manually, but with such systems or with the help of AI, this is something that can be done quite easily. And the last one, it's a little bit similar to harmonizing data from different sources. You can complete data records. So if some information is missing, then you can try to look it up and find it somewhere. One example how such completing of data records could look like is also based on image data again. So I brought here a simple pack shot of chocolate chips thing basically, and I asked one of such foundational models to give me all the relevant product data as a list or a table or something like this. And this is basically what you get out of it. So I don't want to read it out now, but you can see here on one view basically that everything that is written on the package is recognized and basically also sorted or matched to what it is. So basically the name, the brand, how to store it, and the nutritional values and so on. So you don't have to do all this manual stuff and typing all the information into your system, but you can all simply take a picture and then basically you can extract this information. Of course, there might be issues, or there might be recognition errors, things like this. So it's not a universal solution that you can say, oh, now I have such a model and I can do it and all my problems are solved. But it can be a great help because it helps to speed up things. The second trend I brought for Jay is basically automation. I think some of you might know that there are now these fully automated retail stores where you don't have any cashier personnel, for example. You can either scan the things yourself, or there are self-scanning checkouts, or even better, there are the situations where there's a lot of camera and other sensor technology integrated in the stores, and you can simply go and grab the stuff from the shelves and simply leave the store, and then it's automatically booked on your credit card or things like this. And this is also something that might help in situations where there are not so many people, for example, in rural regions or in, for example, outside of the main operating hours and things like this. And then, of course, there's also, again, a lot of artificial intelligence involved if you have these fully automated stores. I brought a small example from our lab. That's our intelligent food crate. And basically, it's two demonstrators in one. So on the one hand, we are checking here. You can see here we have digital price tags basically based on a display. And now we see here some employee. And for example, if the employee now starts to rearrange things, then you can see the price tags are automatically updated. So it doesn't need to be display. It can also be such electronic shelf labels, so the small ones that are placed directly in the shelves. And this is based on RFID technology. So we have the small RFID checks there. And you can, as you have seen in the animation, store a lot of information in there. But also there's a different type of information based on the content of the thing. So with the RFID tags, we basically detected the boxes, but we also have a solution that is done without any RFID technology based on camera image. You can see here. And then this is where the machine learning or deep learning comes in. And you can see in a second, the images are analyzed using a deep neural network. And basically, really the different fruits are detected. I hope you can see it on the screen. You can see what happens then in the end. So during the day, for example, there's a lot of mess occurring because people put their things back in the wrong box and so on. And the system can automatically detect this because it really detects the individual fruits, and then it can send, now you can see it here, send a warning to the store manager, for example, that there are some misplaced fruits or other things for example, empty boxes or things like this that you can detect automatically, and then basically the store manager can react and then can send out someone to clean up the mess or to refill the boxes and things like this. The third example I brought, it's under the topic fun and experience, and you might now answer the question, why is fun something that is important? It again has to do with the basically competition between online and offline. So the question for the offline stores is, what do I have to do so that people will come and visit my store if it is so easy to buy stuff online by just simply going to a web page and order something and then it is sent to me. And so the idea is that you offer them something which makes fun to visit such a store, or give them a specific experience why they think, yeah, that's nice, I want to enjoy my shopping trip there. And one example we brought here is from a fresh food counter, basically, and we termed it natural interaction. So the idea is to bring technology in, but without having the need that people change their behavior. So for a lot of technology we use today, from which we say, oh yeah, it's intuitive to use, it's basically just because we learned how to use it. So we now know how to zoom in a digital map or things like this, but it's not really intuitive because we first have to learn it. And the example you can see here now is a little bit different. We used again AI technology. We have a depth camera here and such a spotlight, which can be controlled basically. And now what happens is when the customer approaches this fresh food counter and he's interested in a specific product, he can simply point at it. So basically the same gesture he did all the time before. He simply pointed at the products he's interested in, but now it's absolutely clear where he's pointing at. So it's not just, I have to ask, do you mean this product or this one? Because it's not so clear where you point at. And as you can see here, for example, you can show additional information like a wine proposal for the cheese, and also the employee on the other side of the counter can see this information on his scale, and then can directly help the customer and again give him additional information, or for example show him such recommendations like the wine or a recipe or things like this. And so the interaction is basically the same as before from the customer perspective, but the value he gets out of it is much higher. And this is one of the ideas that customers that shops can follow to make the stay in their shop more enjoyable. Other things that include, for example, virtual reality or augmented reality experiences. So as I said, based on the idea that there's some unique value you can bring to your customers so that it's worth visiting your store. With this, I'm already at the end because we are also a little bit short on time already. So just a quick recap. So basically, we see that artificial intelligence offers really a great development potential for retail on the one hand, but also in interaction with connected domains. So we are also investigating how the interaction between your home environment, where you also have a lot of smart technologies nowadays, and the retail sector can look like. And as said, really the good databases is really necessary foundation for many other processes, because a lot of them are automated or could be automated if the data quality is good enough, basically. And here artificial intelligence can really help because it can help you maintain good data basis. And as I said at the end, the shopping experience is something that is becoming increasingly more important for the customers, and the interaction should be really made as intuitive as possible, so that the learning curve basically is in the best way not existing, because there's simply no learning involved at all, because in contrast to what we have seen, for example, in Sönke's talk, where we are talking about employees that are in their working environment, we are doing the shopping in our leisure time, and so probably we're not so happy about having to learn something. And that's where we think artificial intelligence can also help, because it can simplify things. With this, I'm at the end of my talk. Thank you, and I'm happy to take any questions.
All right, thank you so much for your presentation. And now we are a little over time, but to be fair, I mean, you still had 5 minutes. I want to use that time to go into question and answer mode. And we have a first question here. Is the AI foundation model or KI foundation models open source?
So there is not one foundation model. So there are many, and there are also open source foundational models. Yeah.
Does that answer your question, or do you want to ask more into that? In the meantime, I can put on the next question. The product information extractor, could you tell the efficiency accuracy rates in some of the projects you have implemented?
Yeah, it's varying. So of course it depends on many factors basically. So on the one hand, it's things like also font size, contrast, and things like this. Also the type of package. So what you have seen on my screenshot, it was quite easy thing because it was a rectangular paper box. Basically, that's quite easy. Other things like, for example, rounded, so like a can, for example, is more of an issue. Also, if you have things like reflections, so if you have such a silver bottle thing or silver can with, from Coca-Cola or things like this, where you have a lot of reflections, or other things, as I said, a bottle, for example, which is semi-transparent, things like this. So I don't think there's one accuracy rate you can mention there. It really depends on the context, and it also depends on what you want to extract. For example, if you have things like the nutritional values, I think it's much more easy because there's a certain structure. Of course, there's different representations, so there's not one structure, but like, I don't know, let's take 40 or 50 at most different types of visualization, and it's absolutely clear what is written there, and it's much easier to find than this information if you know what you're looking for. While in others, situations, like for example, you have seen on the screenshot, maybe there was information on how to store the product, which is something that is probably not present on all different items. So it's not so easy, or it's a little bit more difficult to then find such information, or to also know or then select what of this information you find is really relevant, and so on. I hope this helps and answer the question a bit.
Yes. Someone is typing. If not, we don't have more questions, but a few people already left because of the time, probably. So if there's no urgent questions, I would suggest we end the webinar part and get into a breakout room to get to know each other if you still have time, and maybe if you want to network with the speakers. Would that work?
Yeah, so I have one or two more minutes, but then I also have to jump into the next meeting.
All right, okay. So thank you for your presentation and for this webinar. And before the recording ends, just the information. The webinar can also be attended later, so you don't have to attend it here, or you can rewatch it later. And yeah, and with that, I will say have a nice day. And it was an honor having you too for the official part.